नीचे ही बैठी हूँ।
स्पीकर तो दोनों स्पीकर को तो बुला लो।
स्पीकर को बुला लो।
दोनों स्पीकर। Ladies and gentlemen, there are two Science Day lectures today. Lecture 1 is on telecom technologies for making India a developed nation at 2047 by Professor Bhaskar Ramamurthy sir from IIT Madras. The second Science Day lecture is by Professor Urvashi Sinha from Raman Research Institute, Bengaluru. I would like to request both the eminent speakers to come up on the stage, and I would request all of you to give a round of applause for Honorable Professor Bhaskar Ramamurthy sir and Professor Urvashi Sinha ji. Professor Urvashi Sinha ji, please join us on the stage. I would request Dr. Rashmi Sharma ji, Head NCSTC, to come on the stage and please felicitate with potted plants to Professor Bhaskar Ramamurthy sir. और आप सबसे तालियां प्रार्थित हैं. Ladies and gentlemen, I deem it a pleasure to extend a very warm welcome to Professor Bhaskar Ramamurthy sir from IIT Madras. It is my privilege to tell in brief about Professor Bhaskar Ramamurthy sir. Professor Bhaskar Ramamurthy got his BA Tech in Electronics from IIT Madras in 1980. And his MS and PhD is Electrical Engineering from the University of California at Santa Barbara in 1982 and 1985 respectively. After working at AT&T Bell Laboratories for a couple of years, he joined the faculty of his alma mater in 1986. He served as Director IIT Madras during 2011 to 2021. His areas of specialization are communications and signal processing. His research work is in wireless networks, modulation, wireless data, and audio and video compression. He heads the Center of Excellence in Wireless Technology located at the IIT Madras Research Park, which is focused on emerging wireless standards and technologies. He is a holder of several patents related to 4G and 5G technologies and was the national coordinator for the project to build an end-to-end 5G test bed. He has served as the chairperson of TSDSI. He is currently a part-time member of TRAI. He is also a fellow of the IEEE and INAE and honorable fellow of RWTH Aachen, Germany. I request you, sir, to bless us with your words of wisdom. And I request all of you a round of applause for Professor Bhaskar Ramamurthy, sir.
Good afternoon to all of you. Very, very difficult after lunch, huh? Aye. Good afternoon. So, I don't look like that anymore. I sent a more recent picture, but I think they pulled it out of the web and put that picture. I looked at it, I said, who's that? Then I said, okay, this is a very old picture of mine. I apologize. Can I have the presentation? How much time is half an hour? Huh? No, huh? 20 minutes, 30 minutes. Okay. Anyway, so for those of you who are looking forward to some kind of a talk on what the G-whiz of telecom, what you're going to have, 10 years from now, holograms, this, that. So unfortunately, that's not the kind of talk I prepared, because I take titles very seriously. The title I was given was this. And the other reason also is that if you just think back about the last 20 years, I don't think anybody honestly could have said that in 2000 they could have forecast what would be available in the hands of users of telecom 5 years ago. The smartphone itself came out of the blue. It was not something that was forecast. So I think it's foolish to try to figure out or try to claim to know or forecast what might happen even 15 years from now, 10 years from now. Maybe the next 10 years we can, but not beyond that. So, and so for all the school children who are here, I'm sorry, I'm not going to give you one of these, dazzling talks on what you might get. Rest assured that the technology of telecom has been growing so fast and improving so fast that you can expect unbelievable computing in your hands, unbelievable user applications and so on. But what I'm going to do is really look seriously at what does it take in the telecom area. It's one of the important components of an economy. What does it take for a country like India, the size of India, the place, the point it occupies today in the trajectory of development, to become a developed nation in 25 years? So this is what I'll try to do. This is going to be a talk which is going to show the very a complex intertwined interplay of science, technology, business, national security, all of these things put together. You can't attack this problem or this challenge along in one axis. You focus only on the science, say, I'm a scientist, I don't really understand the other things. Very likely, you'll either, whatever you've done, even if you've done good work, you'll probably fail to make a mark as a technology, as an application in the market, because it's found wanting, or the approach you have taken is found wanting in the other two or three axes. Or it might actually be shot down by the competitors using your weakness in the other axis. And this has happened to India quite a bit in the past. So after the talk, if I'm able to convey to you the complex interplay of various things, various aspects, maybe you'll be able to figure out where we might have actually had difficulties in the past. Next slide, please. So a very quick primer. What are the key technologies that are involved today in telecom, in providing telecommunication service across the world, across a nation as big as India? Well, there is wireless communications. All of us use phones. All of us have one in our pockets right now. It's communicating using RF technology, so there's wireless communications. There's a lot of optical communications. Nowadays, you're a little more familiar with it because optical fiber are coming to many homes. But for the last 40 years, it's been there behind what you see on the towers, behind what you don't see at all, what actually enables the communication to happen. There's a lot of optical fiber buried in the ground, under the sea, and this carries, tons of data, terabits nowadays, right? Even petabits per second of data, and from everywhere to everywhere. And then, of course, in the last 10, 15 years, the increasing role played by computing and the software that goes with computing. Now, there's so much computing on your phone, but there's also an enormous amount of computing in the data centers. And the telecom network itself is now running more and more out of software in these data centers, not to mention the software that is actually at the back of all the applications that you use. These are broadly the three areas that are very important technologies that matter to telecom. There are also other critical technologies, but they are one step removed from those three. Semiconductor technology, everything, all of this, whether it's wireless, whether it's optical, whether it's computing and software, it all runs on chips, on ICs. So the semiconductors that go into your phone, the semiconductors that go into on the equipment on the tower, the semiconductors that go into the data centers, it's very important. There is space technology. There's a fair amount of dependence on satellites. Satellites are used for communication because you can literally go from anywhere to anywhere in the world without any physical connection. But it's also now very critical for such things as GPS, even for giving timing and so on. Satellites are the ones that provide it. So you need space technology to launch satellites and so on. But certainly its connectedness or its adjacency to telecom is much further away than, say, semiconductors. Display technology. Ultimately telecommunications there's a lot of communications going on between machines, but a lot of communications happens to human beings. So you need user interfaces. Displays are very important. So the smartphone revolution happened partly because of tremendous developments in display technology. Non-volatile storage technologies, you have so much data going from point A to point B, very often you have to store the data at least temporarily, if not for a long time. So a lot of storage technologies. And then now, increasingly, quantum technologies. Initially, mainly for secure communications, but later on it may play even other roles. Next. Now, what about is telecom something that's just there as an important part of the economy by itself, or is there wider ramifications? Well, there are much wider ramifications. Telecom is a very, very critical role for the general economy and for national security. For one thing, productivity increases tremendously due to the efficiency of telecommunication versus physical connection. So we get so many things done in the economy much better because we are able to communicate instantly from across vast distances, not just with voice, but with data, with video, and so on. And that increases productivity in every sphere. But also because today, for example, all of us know that even financial services, your UPI, everything depends on telecommunications. It's also vital for national security. First of all, economy is a very important part of the national security. So straight away, if something is so important for the economy in general, it is important for national security. But it's also war fighting. When you get into wars, war fighting now is very network centric. Everything is connected. Everything is exchanging information. All the tools of war, the people at war, and telecom is the backbone for that. Internet denial. So internet is the way by which we send data from any point to any point in the world. Denial of internet and cyber attacks. These are all legitimate tools of war now. If you're at war, you try to disrupt these things in your enemy's country. And telecom is its own vulnerability as far as this is concerned, because it actually is the means of connecting. So in as much as you are doing a great job of connecting various places together, the same connectivity can be used to attack those elements by which you connect them. So it is inherently very vulnerable to sudden remote attack with surprise, to bring down your network or to steal information and so on. Therefore, telecommunications is a very, very critical part of, or has very critical impact on national security. Next slide. So what are the sizes? I said the business plays a very important role. It's very important to understand, even if we are only interested in science, mostly, it's really important to understand what we are dealing with. What's the size? How many crores, thousands of crores, lakhs of crores, billions of dollars? What is involved here? So it's very easy for me to throw a number, and there'll be so many zeros. For most of us, and especially for young students, I think it would mean nothing. I've tried to do it differently. There are about 30 crores families in India, give or take a few crores, right? And every family, and there may be something like 90 crore phones. Many families have 2 or 3 phones. Some families have only one. Of course, small children don't have them. So it's something of that order, okay? Maybe a little less, but... and the average price of the phones that is being sold today to Indians, this figure can be obtained very accurately. I won't get into how, but is about 16,000 rupees today. Okay, of course, many people buy expensive phones. Many others can't afford it. That's the average. That's about 15. So the amount of economic value locked into your phones in the Indian population is about 15 lakh crore. Okay, these phones are replaced every 3 to 5 years. It's partly designed into the phone, so you can't help it, but partly many of us who can afford it also keep buying new phones. And so the yearly investment in phones is about 4 lakh crores. This figure is fairly accurate. You can look it up. Okay, and that's how much Indians are spending on phones every year. There's not many things on which Indians spend, single item on which Indians spend so much. Okay, the telecom network, the rest of the telecom network to which your phone connects, the investment, surprisingly, is actually lower. This number can be debated a little bit because what the companies put out includes the investment in even digging up the roads for putting the fiber and so on. It's not easy to separate out what goes into the technology. I have a sort of a guess that it's about 1 lakh crore. Somebody may say it's 1.5, 2, I don't know, but it's that order. It's definitely less than what we are spending as subscribers on phones. So, till recently, all of this has been imported. All of it. Not very different from our situation with petroleum. And so we can't really afford as a country of this size to import $65–70 billion worth of electronics. Most of it is electronics every year, and it keeps going up. That's one problem, economic problem. Then the technologies involved in this, what goes into this, are very complex and changing very fast. And you know, you can't also say that let's go to the other extreme, let's not import anything, let's make everything. You can't really do that. You can't be really good at everything. So you have to own a part. You can't just isolate yourself from the world and say, I'll do my own stuff. You have to actually be a part of the world. You have to own a part of the global pie. Just like you're importing today, others should import some of what you make. You should be a supplier globally for some things, one of the best suppliers, and you should buy other things. This is about the only way in which it will work. Next slide, please. And the second question is, you know, we are a large country, 1/5 of the 1/6 of the world. So even land area is quite big. We are, you know, in any parameter you use, we are fairly up there as a country. The question is, you know, can we really afford not to know? You may not make everything you use in telecom. You may import some things, but can we afford not to know how to do it? Can anything of vital part of the telecom network or of great value, economic value, vital part could even be of small value, but others could be that it's a very large part of the network in economic value-wise. Can it be something like a black box to us? Answer is no, because global supply chain disruptions can make us very vulnerable. We saw what happened. It didn't really go very bad, but went quite bad when semiconductor supply chains were disrupted, right? Automakers couldn't make cars. The phone production didn't get affected as much, but it could have got. So even when we are not globally competitive, as I said, we cannot possibly be globally competitive in everything. We should hope to become so in a few things. We must maintain viable Atmanirbhar options. So typically you must have in your country some tier 2 or tier 3 supplier. Not having a significant market share, but maybe 5% something, right? And also, if we as a country are critical suppliers for some parts of the telecom network, then there are other critical suppliers on whom we depend are also dependent on us. So there is mutual dependency, so your supply chains are less affected. Okay? If you want to understand what happens there, just think of the vaccine problem that occurred in 2021. Think of countries that neither had vaccines of their own, nor they had the ability to buy the components of the vaccine from anywhere to make them. And think of a country like India, which had a vaccine of its own and therefore could get the components, what it needed to import. And think, so if you think of this, you can understand where the vulnerabilities come from. The other last point is that we are a large country with a large population. We have to gainfully employ everybody. As the aspirations go up, people want to do things that are interesting. They want to do the things they like. So you have to enable such employment. So you have to do a lot more of the things yourself, even if you could afford to import more. Okay? Next. Software is becoming particularly critical because software now resides everywhere. It's in your phone, it's in the data centers, it's in the towers. Software is everywhere. And there are no supply chain issues with software. Software doesn't have any big problem. Once it's there, it can be sold instantly in many copies, as many copies as you want. But there are vital security concerns. If the operating system, I hope you all know that every computer, whether it's your phone or whether it's a data center, has an operating system that runs it. If the operating system in the equipment is not open source or is not owned by Indian entities, and if there are black boxes in it, then we really cannot be sure when it might be turned off or turn itself off, who it will send data to, and when it might malfunction, and so on. And these things have already happened. These things have already happened under various circumstances, so the vulnerability is very severe for a country of our size. And besides developing software, and software is never static, software keeps coming out, new versions. All of us have used Windows, Android, and so on. You see, they keep they keep downloading to you updates. So it's changing on a continuing basis and leads to a lot of gainful employment. So we have to be present as a globally competitive entity in telecom software. Next. So what is Atmanirbharta in telecom? Right? We must control the design of all equipment. Control, when I say control, it means we must have it in our control. I think my language is a little wrong. We must have it in our control. Hamare bas mein hona chahiye. Even if we choose to import some of it, as I said, we can't be the best in everything. We must know what is going on in it 100%. We must understand it. It must not be a black box to us. And we should be able to drop in replacements into it when needed because of supply chain issues. We must make many of the critical components that go into the telecom network. We can't be making all. We can't be the best in making all, but we must know how to make all, but we must be globally among the best in some of them. And we must have at least tier 2, tier 3 suppliers in many of the others, and we must have mutually dependent critical relationships with other suppliers of critical components. Indian entities should own and control the source code of all software. This is very important. Having the binaries is no use. You have to have the source code. We must control it. Not all of it must be written here, but you must own it and you must control it. This is vital for security. And our foreign exchange equation must be neutral. That means we must earn as much by exports as we import, or modestly surplus. I'm not a great fan for having huge surpluses as one country does, because I really don't know. Actually, the fact of the matter is, it's very hard to know what to do with that cash that actually belongs to another country, right? It's much better to run a better equation. But at least it must be in this fashion. Next. So what about intellectual property? That's the last aspect. So again, you cannot become part of the global supply chain, competitive among the best in some parts of the equipment or the components, without having ownership of the IP that is embedded in that. You can't be a leading supplier of displays if you don't own some of the IP that goes into the making of displays, simply because you will be not competitive with somebody who does. And also, the IP that's embedded in these devices, the patents that are involved in making a display for your phone, the chemicals that go into coating the display, the electronics that goes into it, whatever. The patents actually are there to prevent copycats. So if you don't own patents, which you can also cross-license to others and license others' patents, you can't be a significant player in any part of these markets. But there's also another aspect of IP in telecom. In this, it has some similarity to pharma, but not too much. And that is something called standard essential patents. So there is patents in everything you use to build telecom networks, but there are also patents called standard essential. What are these? So first thing is the next, in order for me to talk to you, there has to be a standard. I must be speaking in a standard language with a standard grammar that you understand. Otherwise, you can't understand what I'm saying, right? Otherwise, we can't communicate. So telecom naturally has to have some standards for two entities to talk to each other. And these standards are now global because you are flying somewhere, or you're communicating with somebody from the other side of the earth. The data you send, that one must understand. The data it sends, you must understand, and so on. So these standards have to be agreed on, and they can be changed every few years, but they have to be agreed on. What goes into the standard, if it is backed by a patent that I own, then everybody who uses the standard, which means pretty much everybody who's using telecom, has to license that patent from me. And I will collect royalty. So I will collect a tax I could not even be making anything. I could just have my patent in the standard. Very often, it's not easy to get a patent into a standard if you are not part of the manufacturers and the big players. So very often, the ones who have the patents that are standard essential are also people who are making equipment, and they cross-license to each other. So anybody who doesn't own these patents, some of these patents, very difficult to become a player, very difficult to become a manufacturer, because you will have to pay for everybody else's patents. Okay? So this is another very important aspect. You cannot be a developed country in telecom unless we have not just the IP for becoming a globally leading supplier of some equipment, of some components, IP embedded in those equipment or components. We must also have IP that is embedded in the standards. Some of the IP. Everywhere, I want to emphasize, you can't do everything. You've got to be a critic. You've got to be a commensurate part of the global ecosystem. Next. So what the last part is, what will it take for us to become developed in telecom in 2047? So we must be a proportionate, commensurate, significant owner of telecom standard essential patents. I just mentioned that. We must be a tier 1 global supplier for several telecom equipment and components. Not all, again, commensurate. You know, if we are 1/5 of the world, maybe 1/5 of this, okay? Where we are not, we must have tier 2, tier 3 vendors and mutually dependent relationships with other critical vendors. If you see what are typically called the developed countries of the world, and you check box all these things, you'll find they meet all these requirements. Okay, I don't want to take names and examples, but you can do it yourself. You must have a couple of, you know, it's all, telecom is not like the armed forces of a country. It is run in the private economy, private sector economy. So you must have brands, otherwise you can't be a global player. You must have a few brands which are global from India. All the telecom software and the equipment deployed in India must be of Indian controlled, Indian owned. This is for national security. It's very important, right? And the last is, we must nevertheless know how to design, how to make any one of these things. No equipment can be something that we don't know how it works or how to make it, okay? Though we may not be a leading player in all of them. Next. So where do we stand today? What is what we need to be? Where do we stand today? So we pretty much know how to design and make significant parts of the network equipment. The network equipment is what is outside, not in the phone in your hand, not in any device in your home, but outside, in the towers, under the ground, at the data centers and so on. I think we know how to design and make significant parts of this, okay? Most parts of it. There are some parts which are black boxes, and there is some work going. I think the science of this, and even I would say some of the technology, in India we pretty much understand it. It's not that there are some other areas where even this might be, I would say in semiconductor manufacturing, for example, this is still we are not in this position. But in telecom equipment, I would say we have a fairly good handle on this. However, and we are also actually increasingly part of the network equipment that is deployed in India is now increasingly every year. Higher proportion is being supplied by by manufacturers in India, who have the IP, who have value addition, who know how to make, and who have designed the equipment themselves. Even if the semiconductors in it are imported, okay? Exports are yet insignificant. I remember we said we must be a global player in some of these things. It's still insignificant. And this is very important for benchmarking quality of our equipment. The others are willing to buy it, and also for our foreign exchange equation. So this is something still needs to be, I think we're just about getting started. All semiconductors in this equipment are imported today. We don't make anything here. We know how to design several of these chips because there are entities in India that are designing them for others. And I would say, again, this is not an area where there is a big black art or something. I think we know how to do this. However, there are no Indian vendors of ICs. It's like saying I know how to make good idlis, but I don't have the wherewithal to set up a good restaurant and sell idlis, right? Just can't do it. Just don't. Nobody will come to me. People go to others, even if their idlis are not as good as mine. My prices are higher because I don't operate at the scale at which the others are operating. So everywhere I'm not able to make a dent. So I know how to do it, but I'm not there. Okay, that's really what the situation is. And there are no fabs. There's no way to steam the idlis in India yet. We don't have the equipment. We don't make the equipment. We don't even have the equipment. We haven't even bought it and installed it. Okay? So we need to, in the next 25 years, this is of course a huge effort, not just involving telecom, but the auto industry, the energy area and so on. India needs to become global suppliers for some semiconductor components at least, initially based on fabs abroad, but as quickly as possible from some fabs in India too. I'm not talking about this is in the news all the time. I don't think anybody questions the need for this, and the requirement for this is not only for telecom. There's a lot, when you make network equipment, what goes on the towers, what goes in the buildings behind the towers, there's a lot of value addition in this network equipment other than the semiconductors and components through the IP that is involved in implementing it, in actually making it, designing it, testing it, making it to work. and in the software. So there's a lot, so this is a good thing to be in, and we are not making it's not like semiconductors here, as I said, we are already fairly on the way. And I think this is an area where we'll probably, with very high probability, achieve what we need to achieve, is in telecom network equipment. I think there's a very good chance India will be a leading supplier of telecom network equipment, part of it at least, globally. You know, all those things that I mentioned, have mutually critical relationships for equipment that we don't make, and be a tier 2, tier 3 vendor for much of, to cover all the equipment. I think this is something will be there, and since software in this will be largely developed here, I think the security, national security angle will also get improved compared to where we are today. Next. Now there are niche high-tech components. Semiconductors is one of them, but there are more. If you have, you know, your phone is wireless, so there's definitely there are a lot of other components that are involved in wireless communication. You know, there are antennas, there are filters, there are all kinds of things, RF components. And then the optical network. You have lasers, you have detectors, you have optical pumps for the amplifiers, optical amplifiers and so on. You have so many optical components. These are all niche technology components, the ones that I listed as in the, you know, in the first slide at the bottom. In RF niche components, I think we're okay. Basically, a lot of effort has gone on in the last 50, 60 years for our defense requirements, and some of that knowledge has filtered into the telecom commercial industry. I think we're not too badly off. But in optical components, we literally don't make anything. In fact, the market size is such that there are only usually 2 or at most 3 global players for any vital optical or optoelectronic component. And in the last 20, 30 years, things have gone so risky that in some cases, both the suppliers are making the equipment in the same building in a country that I don't want to mention. The same building. Okay? That's how vulnerable you can get. Everything will stop if that building is knocked out. Okay? This is really where things are. And of course, we don't make, some of this is black art for us. I think this is an area where we need to target, and we may hopefully become a tier 1 supplier for at least some of them, and tier 2, tier 3 for the others. This creates a lot of vulnerability in supply chains, this situation. Of course, as I said, we must make sure we know how to. No, we must invest in the science and the technology and the research to make sure we know how to make all of this at the cutting-edge performance levels at which is required today. Maybe our methods or our technologies are such that we can't compete price-wise, or maybe somebody who's already entrenched has 80% of the market. In some cases, we may have only 5% of the market or 10% of the market. It may need some kind of policy support to ensure that these smaller players can also survive. Many advanced countries do this, even though they claim to operate completely in a quote-unquote free market environment. And in some things, at least, we must put in the effort to become a global supplier. Next. Yeah, phones. So the value of the investment in phones was so high in the first slide, if you remember, or second slide, if you remember that. So let's look at phones itself. So only recently, in the last few years, we have started assembling all the phones that you're using. Almost every phone that you're using in India doesn't, and of late, even the expensive phones are all assembled in India. And of course, they're also exported after assembly. And, but the value add, that means you import many of the things that go into the phone, how much do you add in value, is still very modest. In fact, we hardly, add any components of our own, except probably some mechanical components. And we only do assembly and testing. All the components are being imported at the moment, right? But without assembling phones, there's no way you can get if you become if you figure out how to make some component very well and become globally competitive, there's no way you can get your component into phones that are being made by the millions somewhere else. I mean, there'll be a reasonably close competitor right there who will have an advantage, okay? So, next step is to manufacture some of these components in India, because we are assembling all the phones here. We should actually do this. This is a much tougher challenge than in network equipment, because everything here, the scale is in the order of hundreds of millions. Everybody makes things in hundreds of millions per year, and if you don't have that scale, even if you know how to do it equally well, you can't match in price and speed and performance and everything, right? So, you have to do this. This is another big thing that requires, so all of these things is not a matter of pure technology, pure science, it's a matter of I think if I count, at least 6 ministries in Delhi are involved in making sure we can break through in any of these things. Okay? And you know, the other interesting thing is, even if you have these components being made here competitively at scale, if the phone is being designed elsewhere, the phone, right, is being designed elsewhere, then the components that are chosen by the designer will most probably be local to that place. And then it's not possible for the manufacturer here to replace components, because then there won't be any guarantee on the performance, etc., and you know, nobody will touch it. So you need to have what are called ODMs. ODM stands for original design manufacturers, right? OEMs is the equipment. OEM is an assembler, ODM is the one who designs the equipment. So you need to have these companies that actually design the latest, most competitively priced quality performance phones here, which incidentally design in local components, locally, globally competitive, best quality components, apart from several imported components, which are unavoidable, as I said. Okay? We need to do this in parallel. You can't do this one at a time. If you try to create component manufacturers in India without ODMs, it won't work. They'll die. If you have ODMs here, and the components are all coming from elsewhere, an ODM there will probably have a better design than yours, and you're unlikely to be competitive. So this has to be done in parallel. There's another very tricky thing to get into. All of this involves, if you want to make the best quality ceramic filters for RF, you have to know materials, you have to know the science and technology of all of that. You also have to know how to crack this business side of the challenge. There are IP issues, so the law ministry will be involved, the commerce ministry will be involved, finance is involved because there are taxation issues. That's, you know, there are incentives that are needed, like you have now in India called PLI. So there are 6, 7 ministries that are involved in this. Okay. And we need to create a few global brands. You have to have some phone brands which are sold globally, which are recognizably Indian brands. Otherwise, you can't hope to make it in this field. Next. There are also peripheral components for these phones and other devices, right? There are displays, there are cameras. So cameras are such an important part of the phone. Obviously, the people who make the best cameras for phones in the world have a stranglehold on that part of the business, right? So these technologies are also very complex and very advanced, and a lot of embedded IP. Again, we must enter into a few of these and become global suppliers, and then tier 2, tier 3 and others. There's some R&D ongoing in India in display. Some, I would say, there's almost, in many of these things, we have nothing going on. So these are all areas where we have to learn how to make it. As I said, nothing should be unknown to us, but then we have to be able to make it at scale, at price, in price competitive way, and everything. Okay? We missed the consumer electronics bus. So all of this started in the consumer electronics bus when everybody was just having cassette recorders, TVs, and so on. We missed that completely, so now playing catch-up is that much harder, but we have to do it. Next. Okay, the last, the telecom IP, right? So as I said already, we have essential to have Indian SCPs in global standards. These are at best, it's best if these are created and owned by the manufacturers of telecom equipment, because they have a stake in it. But there's a chicken and egg problem here. If you don't have manufacturers, you don't have IP. If you don't have IP, you don't have manufacturers, right? So you have to have a way of breaking this thing. So there's no harm. You can have R&D institutions, you can have academic institutions, you can have others who develop the IP and license it to Indian manufacturers. This can be done to break the vicious circle. A beginning was made with this. Some of you might have read about this telecom standard called 5GI in the 2020 time frame. It was in the news. So this was proposed. This is a minor, not a very minor, but not a major also. A variant of the global 5G standard was proposed from India because there was something that we wanted in the 5G standard from India which the rest of the world was not willing to incorporate. So we actually spun out a version called 5GI, which also got approved at ITU. But then India being such a large market, I think the 5G standard itself decided to come to terms with it and incorporated what we wanted in 5G itself by 2022. So this story is now over, but this is the first time actually Indian entities started owning SCPs in global standards. In 6G, we hope to play a much bigger role. In fact, India has played a major role in making sure some of our requirements are made mandatory requirements of the emerging 6G standard. We did that in 5G also for rural communications. So this is a whole game. I can give a talk on this, but this is something that we have to do. And we must then make sure that in the coming 6G, which will be 2030, 2040 time frame, very much, and then probably there'll be a 7G or something by the time we talk from 2047, that we must be a commensurate owner of SEPs in global standards, and driven, of course, by the best innovations. Nobody puts lousy ideas into standards, and it will, of course, be used not only by us, but by other people in the world. Next. Yeah, so in conclusion, making India a developed country in 2047 requires us to overcome several challenges in telecom technology. The good news is we are not the starting point in everything, but in some we are behind, pretty close to the starting point, and we have to do something quite remarkable in the next 25 years, because having lost a lot of time, it has become that much harder. We have to create one or more global scale manufacturers of telecom network equipment. This, as I said, is already work in progress. I think this will be achieved. Have a fair share of global market for telecom semiconductor parts and niche component markets in RF and optical spaces. This is a much harder challenge, as I said. The semiconductor challenge is, of course, very hard, and that's not only for telecom, but hopefully, as being addressed by itself, telecom will also overcome some of the challenges in semiconductors here. But in RF and optical spaces also we have to do it. We have to have a reasonable value add in the mobile phone. Even the best, strongest countries in the world don't have more than 40-45% value add in the phone. So at least we have to get to that portion, 25, 30%, 35% in mobile phones. That means any phone made in the world must have some significant value add from Indian component manufacturers. And there must be a couple of global phone brands which are actually going from India. And we must own significant standard essential patents and global standards. I think if we do all this, in telecom at least, we'll be a developed nation by 2047. Thank you.
Thank you so much, Professor Bhaskar Ramurthy, sir, for your words of wisdom full of vision, mission, and action. Now, I would like to invite